we're going to begin our exploration of proteins right now. So we're going to draw a very small protein. It's a little too small to be a protein, but it's like the beginning of a protein. A pentapeptide using 5 of the amino acids. Lys, ala, met, val. Don't forget, you need to make them into you got that and this. When they condense, they become this. You lose water, right? Oh, sorry. So whatever's over here, what is over here? Plus, you lost the O from the carboxylic acid, 2 of the H's from that. You're doing that every time you hook up amino acids. Carboxylate condenses with ammonium. So the lys, I'm going to keep everything I see except for the O- on the right. So correct me if I make any mistakes here, but on the handout, lys looks like this, H3N+. Okay, it's followed by a C that goes up to a carbonyl, and it goes CH2 once, twice, 3 times, 4 times, then NH3+. Was it 4 or 3? It was 4, so I'm good. Now you're going to lose the O- attached to the carbonyl because look up here, we have to do that. So don't draw the O- here, please. Connected to the nitrogen of ala. And if you look at ala on the handout, it goes to a C that's got a methyl that goes to a carbonyl. Do not draw the O- on the carbonyl. It's going to hook up to the N of the next amino acid. It loses 2 of its H's. And becomes an amide. Oh yeah, did I say these are amides yet? I forgot. It's an amide. That's what holds proteins together. Real strong bonds, by the way. What the heck's on the met? I think it says CH2 2 times. And then it goes down to an S with a CH3. Did I count that right? Okay. Then we're going to F. We did green already. Pink. NH. Connected to a C that's got a group. And the group in F is a CH2, then a phenyl. Hey. If you're naming groups attached down here, 1, 2, 3, 4, we had a 4-ammonium butyl group here. We had a methyl group here. We had a ethyl group with a thioether on the end here. And here's just a benzyl group. Yeah. I'm not a teacher that makes you memorize those 20 amino acids. Your biochemistry teacher probably is one of those teachers. They will be making you memorize the 20. So those of you who've had a good organic chemistry background are going to have a lot less trouble memorizing structures because you have words for those groups that are sticking at the bottom. And then it's just like 20 of the same molecule with 20 different R groups. All right, so we're coming up to val. I wonder if there's a V in val. Is there a V in val? No. Is it the one that's a sec-butyl group? Bummer. That would have been nice if there was a V. That goes to an NH, goes to a C. This is the end of the chain. So you copy the O- for the first time. Hey, finally. And then val is, she said, sec-boo. Okay. Did I do it right? I hope so. I'm gonna take a quick look at my handout just for 2 seconds. You won't see it. It's over here. Isopropyl with a V? No. It is a V. Oh. Okay, I'm coming back. It is the V. So there's an easy remember way for your biochemistry teacher, not for me. You got the handout for me. Valine's got the V. Valine. So there is your pentapeptide. Then you can do hydrolysis again. Treatment with 6 molar H2SO4. Oh, you be hating on me now. You be hating on me. Yeah, I know. It's not fair. Hydrolysis, huh? You're popping open every amide. Popping them open. Using water. Put OH on the carboxylic acid. Does it say it's in acid or base? Hydrolysis in acid, carboxylic acids end up being carboxylic acid. Hydrolysis in base, carboxylic acids end up being carboxylates. So these are all carboxylic acids. OH, yeah, 4 of them. Oh, I missed one. There's 5. And the amines are all ammoniums. NH3 plus. NH3 plus. I know, totally unfair what I'm doing to you right now. And purple. And there is the answer to product, to answer question B. Sorry. Question A, pentapeptide. B, hydrolysis after 6 molar sulfuric acid in water. And then C, we've got to learn some things before we can do C, D, and E. I'll make it a little small. Oh, I have a small mistake. In sulfuric acid, that will also become a carboxylic acid. Whoa, would have lost a half point there. And there we go. Trypsin. We got to learn what trypsin does. Let's talk about it briefly here. Trypsin's going to cut this thing open. Cut on the C terminal of lyse or ARG. Now, if you look on the amino acid handout, you'll notice that those are the only 2 with an ammonium ion on the bottom. In the R group area, they have ammonium. So it helps you remember what lyse does. Or trypsin, sorry, trypsin. What am I saying? I will go show you. I'm going to stop my share. And I'm going to share with Moodle. Where are you, Moodle? Multiple choice. Snipping tool. I keep going to the wrong spot. That's okay. It's the exam. It's going to be sideways. What was it going to show you? The trypsin. Oh, trypsin, yeah. Trypsin. Rotate counterclockwise. I needed that handout. Sorry. I don't know why I'm doing it. Because I'm thinking 2 steps ahead, and it's not good. Lysine has an NH3 plus on the bottom. Arginine, I lied a little bit. It's got an NH2 plus, but it's got a plus nitrogen down there. The only 2 with plus nitrogen down there on the R groups are here. And remember, those are the ones that trypsin targets. And C-terminal cuts. Okay, C-terminal cuts. Going to stop share and show you what a C-terminal cut means back at Moodle. Not at Moodle, Starboard. So you're looking for lyse and the C-terminal. Here's the amino terminal. Amino. terminal for the protein, and here's the C terminal, carboxyl terminal for this protein. Every protein has a C terminal on the left, sorry, an ammonium terminal on the left, amino, and a C terminal, N terminal here, N terminal, and C terminal. So that's just wording you have to learn. So when I say you're cutting the C terminal of lyse or arg, that means right there with this lyse, you're cutting there. Please use judicious R groups. Judicious. In fact, maybe just to be real safe, I won't have the nitrogen in there. Call that R1. So what's C gonna give? C gives lyse, and it doesn't have pH conditions or anything, so you can give lyse off the handout. H3N CO minus. There's no pH conditions listed. Ding, 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 ding. So just copy the handout there, and plus R1 attached to NH3 plus. R1 attached to NH3 plus. Trypsin is an enzyme that digests protein by cutting the C terminal of lyse or arg. So you'll have many, many cuts every time you do a protein because they have many, many lyses and arg. They'll get cut to smaller fragments. So you see how this helps digestion and things like that? Okay, and you have to learn that chymotrypsin does similar things with different amino acid residues. The residues are the amino acids in the middle of the protein. So chymotrypsin is going to do cuts. Let's see, that was red. Well, I don't know, light pink on the C terminal of the. This is easy. The amino acids that have benzene in them. There's 3. Phenylalanine, tryptophan, and tyrosine. Those are the 3 that have benzene in them. So we have 1 benzene here. You're going to be doing your cut right there. Sadly, I already used light pink. Let's make the cut purple. I used purple already. That's okay. I'll get over myself. Here we go. The cut's going to be there. So I think I'm going to do a left R group in orange. And I'll do everything up to, but not including the carbonyl. Oop. There. R2. So D gives R2 attached to carbonyl attached to, it got clipped, O minus. Hydrolysis. It's still hydrolysis, just very specific hydrolysis. Plus the purple thing. Plus the purple thing. Purple thing, H3N. Plus goes down to that, up to this. O minus and an isopropyl. Wow. I swear I drew an isopropyl. There we go. Almost there. Okay. I don't want to get confused here. I'm just moving my plus charge there. So you clearly know it's for the molecule above. There we go. E, we have to figure out what an Edman degradation does. Eventually, you do have to know that you use phenyl isothiocyanate. Yeah. So look for that chemical. And we're going to go on the tests for help on this one. Because you have to memorize a product otherwise, but the test always has the Edman mechanism on it. And mechanisms always have reactants and products on them. This is the time where you show me how smart you are. I'm giving you answers for a different protein. Can you, at this stage of your organic career, use it for our example here? So let's go find the test and look for the Edman mechanism and see what it looks like after we're finished. So we're stopping our share. We're going moodling, or dude, sorry. We're here. I don't know what happened. I lost my, did I quit the video? Video's still here. Okay, share screen. I'm just losing it, I'm sorry. We're trying to get to Moodle. And where are you, Moodle? I guess that's snip, starboard. Mind me. Where is Moodle? Eh. My meetings. There we go. That's where I was. Okay. Edman, we're looking for Edman on here. Rotate counterclockwise. There's mechanisms in part 3. There's not even a part 4. What? Yeah. Ah, do you see the phenyl with the nitrogen and the carbon and the sulfur? This is not going to help you at all. This is kind of like what we're doing right now. This is the one we're doing right now. We need the one where that chemical is in a mechanism. So mechanisms come up a little later. There it is. Yay. All right. So what happens in the Edman? In fact, let's just be good students right now. We've got this lovely example here. That's what happens during an Edman. And I'm going to have to stop share, start share again. Stop share, start share. And I'm going to copy that little guy here. Oh, really? Where'd it go? I thought I hit Control V. There it is. All right. Sigh, that's all I got. And I don't know if I put it there, I can move it later, right? So this, it looks like only the amino acid on the far left reacts, because that's what happens. It's the first amino acid in the sequence that reacts during the Edman, and that's it. And what happens to the rest of the protein? Well, everything from this nitrogen onwards is here. Copy, paste. Make sure the nitrogen either is an NH2, or I don't mind if it's an NH2 or an NH3+. I don't mind. If I give specific pH conditions, I start minding. But if you're not told anything about pH or acid, like hydroxide or sulfuric acid present, then you can draw NH2 or NH3+. I don't mind. So you can draw them like this. I'm going to copy. I've got this. The beautiful R1. Look at it. R1. Everything up to there, and I'm going to. It's basically. It's going to be this thing here, isn't it? It's going to be this. Or NH2, I don't care. I'll do the NH2. R1 NH2. This is going to be part, is it D or E? I don't even know. It's E. Where'd D go? There's D. E. We'll put E here. With R1 and baby pink, light pink. You can go NH2 or NH3. There you go. And we're going to draw this ring here. And remember, this piece right here is not the piece in this question, it's the piece in this question here. See? What goes there in this question is this piece. Everything starting here, CH2, 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 4 times NH3 plus. Got it? Copy this ring, except the highlighted. Copy the ring. And over here, NH2 once, twice, 3 times, 4 times. CH2, sorry. 1, 2, 3, 4. NH3 plus. And you're done. That's it. It's not that bad, is it? And we want to be able to see everything. Yeah, I can cut off some of the question there. There we got all the answers here. Good exercise. Big finish is coming. Oh, I gotta stop the video. Bye-bye.